This is a video of our tool demonstration submission entitled MPAnalyzer, a tool for finding unintended inconsistencies in program source code. Let me start this video with an illustration of actual source code modifications. This is a piece of source code included in Apache Subversion project, which is one of the most popular version control systems. A struct element EB target is referenced twice. The references were modified simultaneously in January 10, 2004. The modifications were for bug fixing. The modifications changed referencing the address itself to referencing the contents of the address. However, there is one more reference here. This reference was modified in the same way, but the modification was performed 2 months later. This modification was not at the same time with the other modifications. The commit log shows that these three references should have been modified at the same time. That is, the developer wanted to modify these three code fragments, however, he overlooked one of them. What I want to address with this example is, there is a possibility that developer overlooked some of the code fragment in a source code modification task. So we need to prevent code fragment from being overlooked, and also we need to identify overlooked code fragment efficiently. Our solution to this issue is MPAnalyzer. MPAnalyzer takes a code repository of target software and it detects inconsistencies in the source code. There are two functions in MPAnalyzer. One is mining function, which analyzes histories of target software and it finds modification patterns from them. The other is detection function, which detects inconsistencies by using the modification pattern. This is a window of the detection function. By pushing the button, modification patterns are loaded from the database. In this graph, each vertical bar shows a metric for characterizing modification patterns. But in this video, we don't explain those metrics due to time limitation. By using graph, we can select modification patterns freely. The selection result is reflected to the right-hand panel. In this list, each row means a modification pattern. Modification patterns are displayed with their metric values. This list has a sorting function. We can sort modification patterns in the ascending or descending of any metric. If we choose a modification pattern, its code fragment before and after modification is shown in the bottom part. By using this code, we can see how a code fragment was changed to another one. We can also see the commit logs of the chosen modification pattern. Commit logs are very helpful to understand why the modifications were performed. Now we are going to search inconsistencies with these modification patterns. In order to search inconsistencies, we need to specify the threshold of press metric and version of source code to search. In this video, we set 1 as the threshold and specify the latest revision as the detection target. By pushing this button, the detection started. The detected inconsistencies are listed here. If we select an inconsistency, its source code is displayed in the right-hand panel, and in the bottom panel, there is a suggestion of how the inconsistency should be changed. We can also see the commit logs of the modification pattern, which is the basis of this suggestion. By using these information, developer can see whether they need to change each of detected inconsistencies.